All right, to the next step. Now that we have these 3 audio files prepared, we can import them into FMOD and start configuring the project in a way that will be ready to receive parameters from Unity and manipulate the audio assets accordingly. So let's dive into that. Now we have these 3 audio files prepared to be imported into FMOD. Let's start creating the required events. So we'll have one main event that will be nesting 2 sub-events. Let's create a folder that will hold all these events. Let's call it Torch. And within this folder, let's create our main event, which will be called Torch Main. Let's assign it to the master bank. For the main Torch event, we'll configure it as a timeline event. We can add an audio track and start from the first element, which will be the ignition sample. Place it at the beginning of the timeline. Great. Let's call this track ignition. Now for the 2 other layers, we will be holding them within a nested event, 2 nested events. So for that, let's create a new event, call it Fire Main. You can see that it's currently unassigned. Since we need this layer to be constantly looped, we don't need a timeline. We just need an action. So in this action, we can add a single instrument, select this instrument, and drag the main loop into the instrument. Make sure it's looping. Let's go back to the Torch main event, add an additional audio track, and drag the Fire Main nested event into the main event. And now we can see that the Fire Main nested event is referenced. We can zoom out a little bit here. Let's add a looping region. Making sure that the loop region starts immediately after the ignition sample ends. And this nested event can also be triggered at the beginning of the timeline. Let's call this Fire Main. When this event will be spawned, when it will be triggered, the playhead will start playing from the beginning of the timeline, activating all the nested events and playing the actual Torch ignition sample, which is simply laid out on the timeline. So let's just listen and see how it looks like. So the ignition was played, and then when we enter into the loop region, we are still playing the Fire Main nested event without re-triggering the Torch ignition sample. Notice that this is not the loop that is being applied on the audio. This is just constantly playing the Fire Main nested event. Let's add the second loop layer. Let's add a third event, which will be the second nested event. We'll call it Fire Rumble. Again, we don't need a timeline for this nested event. We just need a single instrument that will play the Torch low rumble sample and make sure that this instrument is looping. Notice that this is still unassigned. Let's go back to the main Torch event. Let's call this track Fire Rumble and drag the Fire Rumble sub-event. Let's have a quick listen. So the looping behavior is what we want it to be, but both loop layers are just playing full volume. We need to apply some automation on the Fire Rumble event volume. So when we're selected on the Fire Rumble track, we can right-click the volume knob and select Add Automation. Click Add Curve, go to Browse, and then we're presented with a dialog that allows us to select a parameter. But we never created any parameter in this FMOD session yet. So let's just create a new parameter. We can call it torch velocity. The range can be from 0 to 3. And the initial volume will be 0. It's okay. In the overview panel, we can see the parameters list. And we can see there's a new local parameter, which is a float that moves between 0 to 3. And then in this graph, we can add some points and say, when this parameter is 0, I want to attenuate this audio track, this Fire Rumble audio track, in 40 dBs. And when the torch velocity reaches 1.5, I don't want to apply any attenuation. So let's do a quick manual simulation and see how it sounds. Ignition sound, fire main is looping, the Fire Rumble is completely attenuated, and I'll start modulating the torch velocity float and see how it affects the Fire Rumble volume. So two important parameters that are really crucial for achieving a realistic response from the torch are the time constants of the torch velocity parameter. So if you'll click that parameter from the overview panel, you'll see that you can configure the seek speed of this parameter. You can click the asymmetric, and you'll have two separate values to dial in that will affect how fast or slow this parameter will change when it's ascending or descending. It's important to note that the higher these values are, the quicker the response is. So these are like floats per second. So the attack of the hand movement, the attack of the torch velocity, I want it to be quite fast. Let's say about 15 floats per second. 14 is good enough. And the release, I would like it to be a little slower. Imagine that the wind that is caused by the hand movement isn't stopping in 0 milliseconds. It's taking a little longer to release. So let's say something like 7 floats per second. You need to feel these floats tied with your object. You need to tweak them at runtime when you're integrated with Unity in the actual experience. And finally, we would like to spatialize this event. So let's select the master track, right click, and add FMOD spatializer. Again, you need to tweak these parameters to fit your specific objects, but for this object, I'll make it about 35 centimeters big and leave the curve as this default curve. Let's save this session. All right, we have a prepared FMOD project, and in the next video, we will see how we integrate it with Unity. If you have any questions or thoughts, please leave them in the comment section and I'll get back to you. Thanks.